Right, so before I told you you have a potential energy graph. You have two types. One is curved and one is straight. And we're first dealing with the straight line graph. And then we said if the graph decreases, it's an exothermic reaction. And if it increases, it's an endothermic reaction. Now we're going on to page 218 of your textbook, and we're going to look at how we can use these graphs to show different types of reactions. Right, so first let's look at this example where you have this reaction A2 plus B2 giving you 2AB. Now if you look at this graph, can you see it's decreasing? Reagents, which is reactants, started off high, then the graph decreased, and then products ended up low. So you start from high, you end to low, which means the graph is decreasing. Now if the graph is decreasing, it means it's an exothermic reaction and delta H is less than 0. Okay, so this reaction is exothermic. Now if you look at this graph, can you see we actually have numbers? On the potential energy side axis, we have 90 and 30. The course of reaction, that just means the reaction time or what's happening during the reaction, but you're not going to see any numbers on this x-axis. Right, so we're only looking at the y-axis values. Now if you want to work out delta H for this reaction, remember delta H is equals to energy of products minus energy of reagents. So if we look at this graph, the products is here and the reactants are here, and if we look at it, we can see that the products energy is actually 30 kilojoules per mole. So the energy of the products is 30, and then if we look at the reagents is 90 kilojoules per mole. So this graph is actually giving us actual values. So if we want to work out delta H, we're going to say products minus reactants, which is 30 for products minus 90 for reagents, and that will give you negative 60 kilojoules per mole. Now can you see the answer is negative? And remember we said if delta H is negative, it's an exothermic reaction because you are releasing energy, you are getting rid of energy. And we will expect a negative value because you can see that the graph is decreasing. So anytime the graph decreases, it starts off high and it ends off low, you know that it's an exothermic reaction and delta H has to be negative. If it's not negative, that means something is wrong or the calculation you done is wrong. Okay, now there's many different ways of working out whether a reaction is exo or endothermic, and I'm going to show you the different ways. But the one way from a graph is that the graph will decrease, products will be lower than reactants. Now, if we have different chemical reactions, like if they're actually giving us the formula, we can use the formula to see if the reaction is exo or endothermic. Now, on page 218, we can see there's different formulas here, and all of these represent the same chemical reaction. But they wrote it in different ways to show us that it can be endo or exothermic. Okay, now this reaction we're dealing with, we said it's exothermic because the graph is decreasing, and we worked out delta H to be negative 60 kilojoules per mole, so we know it's an exothermic reaction. Now, there's many ways of showing an exothermic reaction. First of all, you need to know that an exothermic reaction is a reaction where you're releasing energy, which means you're giving off energy, you're getting rid of it. Okay, now if we look at this reaction, the first way that they showed it is A2 plus B2 giving you 2AB plus energy. Now you have this plus energy here, and this plus energy is part of the products. Can you see that A2 and B2 are reactants, and then 2AB and energy are the products? Now if energy is a product, it means you are getting rid of energy, you are giving off energy. Okay, so you're not taking it in, you're releasing it. So since you are releasing it, it means that this is an exothermic reaction. So the one way that they can show it's an exothermic reaction is by writing energy as part of the products. Okay, so you write the chemical reaction, and then as a product you'll say plus energy. Okay, so just remember you write product plus whatever other products you have, and energy will be one of the products. So if energy is a product, it's an exothermic reaction. Another way they can show exothermic reaction is they write the chemical reaction. So you have your A2 plus B2 giving you 2AB plus 60 kilojoules per mole. Now here again A2 and B2 is the reactants, 2AB plus 60 kilojoules per mole is the products. Now, since you have 60 kilojoules per mole, what is 60 kilojoules per mole? It is the energy released in the reaction. It's delta H. So since you have it as part of the products, they're basically telling you that this 60 kilojoules per mole is a product. And if it's a product, it means you're releasing it. You're getting rid of it. So if you write the energy as a product, again, it will be an exothermic reaction. Now, the only difference between the first example and the second example is in the first chemical reaction, they just wrote plus energy, which means they're just telling you that energy is released. It's a product. But in the second one, they're actually telling you how much energy is released. They're not just telling you energy, they're telling you specifically it's 60 kilojoules per mole. So they're being specific with the values. So whether they tell you energy or whether they tell you the exact amount of energy, if energy is a product at any time, it means it's an exothermic reaction. Right, the third way they can show you how it's an exothermic reaction is if they write a chemical reaction and then on the side of it, maybe they'll separate it by a semicolon. On the side of it, they write delta H is less than 0. Now, we know if delta H is less than 0, it's an exothermic reaction. So if they write delta H separately from the chemical reaction, then it will show it's exothermic. And then the last way is if they have a chemical reaction and again separately they write delta H, but in this case they're not just writing delta H is less than 0, they're actually giving you an actual amount. They're telling you it's negative 60 kilojoules per mole. So because you have a negative answer, it means it is exothermic reaction. Okay, so there's 4 ways to do it. If you have energy or the amount of energy as a product, it's exothermic reaction. If they write delta H separately from the reaction and they say it's less than 0 or it's a negative answer, it will be exothermic. Now, I know you might get confused if you see this plus 60 kilojoules and then you will see minus 60 and you know a negative answer means exothermic. But why do you have a positive 60 in this example? Now, the only reason this is positive 60, it doesn't mean it is endothermic because it's positive. It means that this 60 kilojoules per mole is just a product. Remember, when you're writing chemical reactions, you have to separate reactants with plus signs, like how you have A2 plus B2, and products will also be separated by plus signs. So because you have this plus sign, does not mean it's an endothermic reaction. It just means that this 60 kilojoules per mole is one of the products. Okay, so just remember, if energy or the amount of energy is a product, it's exothermic reaction. If delta H is less than 0 or if it's a negative number, it is exothermic. Right, now let's go on to the opposite one, which is endothermic reactions. And also there's many ways of showing endothermic reactions. So remember we said if you have a certain reaction and it's exothermic and then you take the reverse reaction, that reverse reaction will now be endothermic. So if you reverse the reaction, the type of reaction will also reverse. If it was endo, now it will be exo. If it was exo, now it will be endo. Now, if we look at the same reaction, can you see you have here A2 plus B2 giving you 2AB, and this was an exothermic reaction. Now we're going to take this reaction and reverse it. So if we're reversing the reaction, it means we're also reversing exothermic to endothermic. So if we take this reaction now and we swap it around, so instead of A2 plus B2 giving you 2AB, you now have 2AB giving you A2 plus B2. So we swapped it around. So because we swapped it or we reversed it, instead of having negative 60 kilojoules per mole as delta H, now we have positive 60 kilojoules per mole for delta H. And since it's a positive number, we now know it's an endothermic reaction. So just remember, if you reverse the reaction, the type of reaction also reverses. Now, if we look at the graph of this reverse reaction, we can see that this graph is increasing. The reagents are lower and then the products are now higher. So you went from low to high, it increased. So since it increased, we know again it's an endothermic reaction. Okay, and now we can also work out delta H the same way. We remember delta H is energy of products minus energy of reactants, and this graph is actually giving us values. So we have the products energy as 90 kilojoules per mole and the reagents as 30 kilojoules per mole. So if we want to work out delta H, it will be products, which is 90, minus reactants, which is 30, and that will give you positive 60 kilojoules per mole. Right, so this graph is showing us that it's an endothermic reaction because the graph is increasing, but there are also other ways to show if a reaction is endothermic. Now, just like how we show something is exothermic, endothermic will also be shown in the same way, but it will be the opposite. Now, if we're looking at this reaction, can you see you have here the reaction 2AB plus energy giving you A2 plus B2. Now, can we see the difference already? 2AB and energy is now the reactants, and A2 plus B2 is the products. So now, before we showed exothermic reactions and we showed energy was the product. Now with endothermic reactions, we're showing energy as the reactant. So anytime you see energy as a reactant, that means it's an endothermic reaction. And because we know energy in an endothermic reaction is taken in, it's absorbed. So you're taking in. So that means you're using it as a reactant. You're using it up. So it is a reactant. So if energy is on the reactant side of the formula, it's an endothermic reaction. The second way you can show if it's endothermic is if you write the formula. So you're writing 2AB plus 60 kilojoules per mole giving you A2 and B2. Now again, can you see we have the 60 kilojoules per mole on the left hand side, which is the reactant, and A2 and B2 is the products. Now the only difference again between the first one and the second one is the first one you're just saying energy, you're just being vague, you're just telling energy. But in the second one you're actually giving the specific value of energy, which is 60 kilojoules per mole. So because you have energy, whether it's written energy or whether you have a number for energy, if energy is on the reactant side, on the left-hand side of the equation, it will be an endothermic reaction. And can you see that is the opposite of exothermic? For exothermic, we had energy as the product. For endothermic, we have energy as the reactant. Okay, so just remember that. If energy is a product, it's exothermic. If energy is a reactant, like here, it's endothermic. Then the third way you can show if it's endothermic is if you write the chemical reaction. So here you're writing 2AB is giving you A2 plus B2. And then you're writing on the side of the reaction separately from the equation that delta H is greater than 0. We know if delta H is greater than 0, it's an endothermic. So this delta H greater than 0 means it's an endothermic reaction. And the last way you can show if this is an endothermic reaction is again, if you write down the chemical reaction and separate from that equation, you show that delta H is equals to positive 60 kilojoules per mole. And since you have here a positive answer, a positive number, it means it's endothermic. So these two bottom ones are the same. It's just that here they're just saying greater than 0, and here they're actually giving you the amount. So those two are the same. Right, so let's just summarize quickly. Now there's many ways of showing if something is endo or exothermic reaction. If the graph decreases, if it goes from high to low, it's exothermic. If the graph increases, if it goes from low to high, it's endothermic. If you write energy or the amount of energy as the product of a reaction, right, it will be separated by plus signs. It is an exothermic reaction. If you write energy or the specific amount of energy as the reactants, it's an endothermic reaction, and again you will have positive signs. So whether it's positive signs, it can be endo or exothermic. Is just that exothermic is on the product side of the reaction and endothermic is on the reactant side of the reaction. If they write delta H is less than 0, it is exothermic. If they write delta H is greater than 0, it is endothermic. If they write delta H is a negative number, it's exothermic. And lastly, if they write delta H as a positive number, it is endothermic. So you just need to make sure, are they telling you delta H or are they writing energy as part of the reaction, and that will be able to tell you if it's an exothermic or endothermic reaction.